Yes, students are joining. So let's wait for 1 or 2 minutes to the students are joining. Jahiruddin Hussain, we were concentrating on the measurements and errors and units and dimensions, man. Yeah. We'll start. We'll wait for 1 minute. Like students are joining, offline, online, both students are joining. Let's wait for 1 minute. Best College, CBIT versus JBIT. Hmm. Like if we see in the fee structure now, JBIT is the least fees they are collecting. So placement point is the main thing when we choose the college na. So it depends upon the college, like each year it may varies. Okay, so once you can check out last 5-6 years how the placement has been taken place and what are the companies has been came there. Okay, yeah, let's start the class. So we were discussing about measurements and errors and units and dimensions, right? So in last class we were solved some questions. No, yes, this was the question I gave homework in the last class. Let us see how we can solve this question. So calculate the percentage error in determination of time period of pendulum. So T is equals to 2 pi root over L by G. So where L is given as plus or minus 1% and G is given as plus or minus 2%. This was the given question. Okay. So when we see this now, like they are asking the measured with 1% and 2% and they are asking the percentage of time period. Okay, so constant, no need to worry about that constant. So L power 1 by 2, G power minus 1 by 2. Can I write like this na? So delta T by T will be equals to 1 by 2 into delta L by L plus 1 by 2 into delta G by G. Okay, so we were seeing this formula in the last class also, how to take when the powers are given, right? So it will be equals to 1 by 2 into 1 percentage plus, let me take this plus or minus outside, okay, 1 by 2 into 2 percentage, which is equals to 1 by 2 plus 2 by 2, which is nothing but plus or minus 3 by 2 percentage. That's it. Right? Yeah. Next one, we were discussing about the dimensional formula of the following quantities. Like I asked you to find these dimensional formulas in the last class. I have given this as a homework, no? So let us solve this question, and once you can cross verify whatever the answer you got and whatever answer we are getting, okay? Yes, the first one let us find. So first one, density, right? So density is nothing but mass by volume. So mass by volume, and one more thing, the dimensional formula whatever we are writing, no, it should be in the square bracket, the first thing, okay? So mass, it is kg, na? Yes. So m, mass m, and this is kg per meter cube we are writing, no? So meter cube, so L power minus 3 T power 0. This is the first one. Right. So for the second one, the dimensional formula we have seen, but once again we can do it here. So velocity is nothing but displacement by time. So meter per second, right now. So meter length, and yes, seconds t. So m power 0, L power 1, T power minus 1. L T power minus 1 is the answer for the second one. What about the third one? Acceleration. Acceleration is nothing but velocity by time, which is nothing but meter per second square, right now. So what is the formula now? I mean dimensional formula, m power 0, L power 1, T power minus 2, right? This is the formula for the third one. So what about the fourth one if we see? So fourth one, momentum. Momentum, mass into velocity, right? Okay. So mass kg, velocity meter per second. So this is the SI unit. So m L T power minus 1. ml T power minus 1. Then force, E force, kg meter per second square, mass into acceleration, no. So this is my SI unit, that is Newton. So kg m meter L second square, T power minus 2. ml T power minus 2 is the answer for the fifth question. So when we talk about the sixth question, that is what is that? Work and energy. So sixth question, work is nothing but force into, let me write, force into displacement, right? So force is mass into acceleration, this is one, and displacement is like let me take x, okay. So force, we know that we have got the force, that is m L T power minus 2. What about the displacement again? L. So m L square T power minus 2. This is the answer for work done. Then what about energy? Energy we have solved, but once again we can see here, either we can take of mv square or else mgh, either potential energy we can take or kinetic energy. And work done or energy, both are same only, right? Now see, mass m meter per second, so whole square, so L power 2 T power minus 2. When I do for this one, mass m, and this one is meter per second square, and again meter, so L power 2 T power minus 2. Are we getting the same one? Yes. So for the F question, like sixth question, this is the answer, okay. And what about the seventh question? Seventh is power. So power is nothing but work done by time. So work done, we got the answer, right? So m l power 2 t power minus 2 divided by t. So m l square t power minus 3 is the power dimensional formula. Then pressure. Pressure is nothing but force per unit area, which is force we got na ml t power minus 2, and when we talk about the area, no, it is L square, right? No, L square. So ml power minus 1 t power minus 2 is the answer. You can take a note of this. Done. So I hope you got the same answers, right? Can we go for the next one? Yeah. So we were seeing the uses of dimensions, conversions of units to check the dimensional of given physical equation, to establish the relation among various physical quantities. So second one, that is to every physical equation should be dimensionally balanced. This is called the principle of homogeneity. Yes, conversion of unit we have seen in last class. Now we are going to go ahead of the topic, that is to check the dimension of given physical equations. Now we will check that equations. Let me take V is equals to U plus AT. Okay, so when I talk about the left hand side and right hand side, if both are equal only I can equate that, I mean I can give the equation symbol right now. So let me take V will be equals to U plus, no, plus, okay, again V will be equals to AT. It should be equal. Yes, no, it should be equal. So what is V? Final velocity. What is U? Initial velocity, right? Na? V and U are final velocity and initial velocity. So V is equals to U plus AT, where V is final velocity, U is initial velocity, and A is acceleration, and T is time. Now let us talk about the SI unit. So meter per second, it is meter per second, it is meter per second square, it is second, right? Now let me talk about V is equals to U. So V meter per second, U also meter per second, right? Na? Like whether it can be initial velocity or final velocity, like whether it changes its unit, no. So it have same unit, so I can say yes. Now V is equals to AT. So here meter per second, okay. What about here? It is meter per second square into second. So second square and second will get cancelled. So meter per second and meter per second. Yes, it is dimensionally correct. It is dimensionally correct. Equation is correct. It is correct equation, we can say now. Okay, so this is how we can identify whether the equations are correct, like it is following the principle of homogeneity. Okay, yeah, you can give a try for this two more equation, v is equals to u plus at we have got na, then v square minus u square is equals to 2a s, or else you can take like this, or like v square one side, u square plus 2a is one side, okay, and then s is equals to ut plus of at square, right. So v square, meter per second the whole square, which is nothing but meter square and second square. Let me, if I take this one this side, no, again same, yes, no, same. So I can say v square is equals to u square, okay, fine. What about v square is equals to 2a s, 2 you leave it, it's a constant, you no need to worry about that constant, okay. When we talk about acceleration, meter per second square. When I talk about displacement, meter, so which is meter square per second square. Yes, it is dimensionally correct, it follows the principle of homogeneity, right. So next equation, so yes, it is meter, so everything should be in meter, no, yes. So this is velocity, meter per second into time, second, okay, second cancelled, okay, it follows s is equals to ut, correct, but s is equals to 80 square also should be there, s is equals to 80 square. So again meter, it is meter per second square, and again second, I mean yes, time is second and square, so this and this will get cancelled, yes, v square minus u square equals to s follows, s is equals to ut plus of 80 square is also follows, right. So we can say these are perfect equations, right now. Okay. Yes. So show that the expression of the time period of the t of a simple pendulum of a length given by t is equals to 2 pi root over L by g. Yes, dimensionally correct or not. So okay, we have done this, and conversions also we have done. Now I have said I will give the dimensional formulas of some important formulas, no, important quantities, na, yes, na. So these are the important quantities, like you can take a note of this, whoever in the offline classes, and whoever watching, no, you can take a screenshot, or else if you are having notebooks in front of you, you can take a note of this, okay. So we'll see one by one. Displacement, okay, the symbol s, x, whatever it is, okay, formula L, and SI unit is meter. Dimensional formula is m L power 1 t, sorry, m power 0 L power 1 t power 0, okay. This is dimensional formula for the displacement. Area, length into breadth, no, so length we can measure in meter only, breadth also meter only, so meter square, so m0 L2 t power 0. Then volume, length into breadth into height, so meter cube m power 0 L cube t power 0. So next one is velocity. So displacement by time, so meter per second is the SI unit. So SI units are important, okay. See, they might ask you the direct question, what is the SI unit of the given quantities, and what is the dimensional formula of the given quantities. So the basic thing only, like you need to remember that, that's it. If you remember, your answer is correct, that's it, okay. So velocity we have got momentum, mass into velocity, kg meter per second. So kg m, meter L, second per second, no, L power minus 1, right. So acceleration, velocity by time, so meter per second square is the SI unit, and L power 1 t power minus 2 is the dimensional formula. Next is force, mass into acceleration, SI unit is Newton. Then m power 1 L power 1 t power minus 2 is the dimensional formula for the force. So you can take a note of this. Okay, can we go next one? Okay, fine. So next one is yeah. So power is nothing but work done by time. So SI unit is watt, and dimensional formula is m power 1 L power 2 T power minus 3. Density, mass by volume, kg per meter cube is the SI unit. Dimensional formula is m L power minus 3 T power 0. Then pressure is force per unit area. So SI unit is pascals. So m power 1 L power minus 1 T power minus 2 is the dimensional formula for the pressure. Then what about the torque? Torque is nothing but SI unit is Newton meter. Okay, so R cross F is the formula. So m power 1 L power 2 T power minus 2. Okay, we know the formula, like a dimensional formula for force, nothing but m L T power minus 2. So into meter one we are adding, so L we are adding, so L square T power minus 2 will be there, that's it. So angular displacement, so displacement, yes, similarly angular displacement is there, theta arc by radius is the formula, and SI unit is radian. Okay, there it is meter displacement, here it is radian. So dimension formula is m power 0 L power 0 T power 0. Okay, so don't ever confuse between the displacement and angular displacement, guys. Okay, so angular velocity, if you see omega is nothing but angular velocity symbol. Okay, so theta by t, angular displacement by time, there velocity is nothing but displacement by time, here angular displacement by time. So radians per second, and dimensional formula is m power 0 L power 0 T power minus 1. Angular acceleration denoted by alpha, this is alpha. Okay, so angular velocity by time. Okay, radians per second square is the SI unit, and dimensional formula is m power 0 L power 0 T power minus 1. Then moment of inertia, which is the formula is mr square. So kg meter square is the SI unit. Then m power 1 L power 2 T power 0 is the dimensional formula. Frequency is nothing but 1 by time period. So the SI unit is hertz, we'll say. Okay, then it is 1 by time period. No, so time period will be coming up, so T power minus 1. Stress is nothing but force by area, so Newton per meter square. Force, right, Newton, area, meter square. M L power minus 1 T power minus 2. Okay, strain is nothing but change in length by original length. Length, no, like change in area by original area, or change in volume by original volume, we'll say. So volume, so same SI unit will be this, so there is no units, same units will be there, no, so no units for the strain. So M0 L0 T0. Okay, so Young's modulus Y, Young's modulus, bulk modulus. Okay, so Y is nothing but for stress by strain, will say. So whatever SI unit we are having for stress, no, the same SI unit for modulus of rigidities. Okay, so M L power minus 1 T power minus 2. So you can take a note of this, of these quantities. So completed? Oh, you need 30 seconds. Okay, complete it fast. We'll go for the next slides. So still some quantities are left out. Okay, important quantities. So till now, no, No doubts, na? Yes. Okay, can we go for the next one? Yes. So some more quantities we'll see. Okay. So the quantities are surface tension now. So surface tension SI unit is Newton per meter, joules per meter square we'll say. Okay. So m power 1 T power minus 2 is the dimensional formula. Then force constant, that is K. Okay. So force constant is nothing but F is equals to Kx. So which is nothing but K will be equals to F by X. No. So 4 Newton per meter. So m power 1 T power minus 2 is the force constant. Next is coefficient of viscosity, which is denoted by eta, we'll say. Okay. And SI unit is kg per meter second. Okay. Or poise in CGS, we'll say poise in CGS unit, we'll say. Okay. So m L power minus 1 T power minus 1 is the dimensional formula for coefficient of viscosity. Next is gravitational constant. So G is nothing but gravitational constant. So F is equals to G m1 m2 by r square is the formula. From there we can write G will be equals to Fr square by m1 m2. So Newton meter square per kg square will say. So m power 1 L power 3 T power minus 2 is the dimensional formula for the gravitational constant. So gravitational potential, so joules per kg, m power 0 L power 2 T power minus 1 is the dimensional formula. Temperature, which is SI unit is Kelvin, will say Kelvin. So it is m power 0 L power 0 T power 0 and theta power 1. Theta is nothing but temperature, will say. Okay, theta. Okay, now so specific heat here, if we say, see here, joules are calories, right? Joules are calories. What is the dimensional formula? M L power 2 T power minus 2. Then some more latent heat is there. Coefficient of thermal conductivity, universal gas constant are okay. So and they have given that m power 0 L 2 and T power minus 2, m power 1 L power 1 T power minus 3 and theta power minus 1. Here m power 1 L power 2 T power minus 2 and theta power minus 1 is the dimensional formulas for these quantities. So you can take a note of these quantities, and one more slide of quantities are there. So let us discuss that and go next topic. Done, no? So we can go for the next one. Yes, so last some quantities are left out, so we can see that quantities and then we can move on to the next one. Okay, that's it. So mechanical equivalent of heat, charge, then current, electric permittivity, electric potential, intensity of electric field, capacitance, dielectric constant or relative permittivity will say, and resistance. So resistance, okay, V is equals to IR, so R will be equals to V by I, ohms this is, and this is M power 1, L power 2, T power minus 3 and A power minus 2, okay. So these are the dimensional formulas, M power 0, L power 0, T power 0 for mechanical equivalent of 8, charge M power 0, L power 0, T power 1, A power 1, okay, and A is nothing but ampere will say, okay. Then current ampere, so M0, L0, T0 and A power 1, okay. Now then electric permittivity, M power 1, L power minus 3, T power 4 and A power 2. So electric potential, like SI units also I have given, guys, so you can take a note of that also. This also is important thing in this, okay. So electric potential joules per coulomb, so M power 1, L power 2, T power minus 3 and A power minus 1. So intensity of electric field, so Newton per coulomb, so M power 1, L power 1, T power minus 3 and A power minus 1. Then capacitance is farad, which is nothing but M power 1, so M power minus 1, L power minus 2 and T power 4, A power 2. Then dielectric constant or relative permittivity. So there is no SI unit for this, so dimensional formula is 0, M power 0, L power 0 and T power 0. Next is resistance, SI unit is ohms, so M power 1, L power 2, T power minus 3 and A power minus 2 is the dimensional formula. So you can take a note of this. Okay, done, na? Done. Okay, one more is left out, guys. Okay, one more topic is left out, that is, yes, last one. So conductance is the first one, specific resistance or resistivity, conductivity or specific conductance, magnetic induction, magnetic flux, magnetic intensity, and then magnetic permeability or free space of medium will say, coefficient of self or mutual inductance, electric dipole moment. So symbols they have given and the formulas also they have mentioned, and we have given the SI unit of the each quantities. So conductance MHO, okay, and resist, like specific resistance, which is nothing but ohm meter. Then conductivity MHO per meter. Then magnetic induction is nothing but Tesla or Weber per meter square. Magnetic flux Weber. Magnetic intensity, which is nothing but ampere per meter. Magnetic permeability, which is nothing but Newton per ampere square. Then coefficient of self or mutual induction Henry will say, and electric dipole moment Cm, that is Coulomb meter. Okay, so the dimensional formulas, if you see here, M power minus 1, L power minus 2, T power 3 and A power 2 is the dimensional formula for conductance. Specific resistance or resistivity, m power 1, t, l power 3, t power minus 3 and a power minus 2. Then specific conductance or conductivity will say m power minus 1, l power minus 3, t power minus 3 power 3 and a power 2. So magnetic induction, Tesla or Weber will say, Weber per meter square will say no. So m power 1, t power minus 2 and a power minus 1. Then magnetic intensity, so m power 1, l power 2 and t power minus 2 and a power minus 1, right. Then magnetic permeability, so m power 1, l power 1, t power minus 2, a power minus 2. Coefficient of self or mutual inductance, so m power 1, l power 2, t power minus 2 and a power minus 2. Then electric dipole moment, so last one m0, l1, t0 and a1. Okay, these are the quantities. So last slide, you can take a note of this and we'll start doing the problems. Okay. Completed. 30 seconds you need again. Okay, complete fast. Done now. Okay. Okay, we can see the next one. Fine. So the next one is, so here is the question. Okay, the third one we have seen, no, the third topic. So what was the third topic? So to establish the relation among the various physical quantities, right? Now we can do a question on this. So the frequency f, okay, f of a stretched string depends upon the tension f, yes, depends upon the tension f, length L of a string and mass per unit length is mu, they have given, of the string. Describe the formula for the frequency. So suppose if we take f is directly proportional to, so small f is directly proportional to capital F, small f is directly proportional to L, small f is directly proportional to mu. So we need to consider f directly proportional to f L mu. Let me take here powers are A, B, C for examples. Okay, if any other quantities are adding, so D, E, F, like I can take it. Okay, so now what is f? Dimensional formula. Dimensional formula for f. So m L power minus 1 or 1, L power 1, T power minus 2, is it right? Right now, so kg meter per second square, right? No, yes, perfect. So m L T power minus 2 power A. Okay, frequency, what is frequency? Like I need to describe the formula, no, here, like derive the formula for the frequency they are asking. So f is nothing but T, no, 1 by T, frequency 1 by T. Okay, now what about length? L power B. What about mu? Mu is nothing but mass per unit length, no. So mass m per unit length, L power minus 1, power C. Okay, power C. Now let me consider over here this one this one as m0 L0 T power minus 1 should be directly proportional to, let me take this powers inside now. So m power A, L power A, T power minus 2A, L power B, m power C, L power minus C. Okay, up to this clear, no? Yes. Now what are the common quantities m, okay, base are same, I can add the powers. M power a plus c, then L is there. So L power a plus b minus c, then t, only one t is a t power minus 2a. That's it, no? That's it. Right? Any doubts over here? M, a, m, c, okay, L, a, b minus c, t, only one t is there. So m power 0, L power 0, t power minus 1, directly proportional. Now if I have here m, L, t, here also m, L, t I have. So directly proportional, no? So I can take a plus c will be equal to 0, then a plus b minus c will be equals to 0, then minus 2a will be equals to 1. That's it. Now calculate the value of ABC. Calculate the value of ABC. So a will be equals to minus 1 by 2. Fine, good, okay. Substitute the value over here. Minus 1 by 2 plus c will be equals to 0. C will be equals to 1 by 2. Okay, perfect, nice. This one we got it. What about a plus b minus c? Let me take a and c, substitute over here. So 1 by 2, minus 1 by 2 plus 1 by 2. Okay, let me take a is minus 1 by 2 plus b minus of 1 by 2 will be equals to 0, right? No? So 1 by minus 1 by 2 minus 1 by 2 minus 2 by 2 plus b will be equals to 0, right? Then b will be equals to 1. Right, no? So we got a, b and c. So we'll write over here a is equals to minus 1 by 2, c is equals to 1 by 2 and b is equals to 1. So let us take the same powers and substitute here. Okay, this is the thing. F is equals to some constant will be there. Let me take that k. Okay, I need to remove the proportionality, right? F is equals to f power, capital F power a is minus 1 by 2, then L power b is 1 and c power 1 by 2, that is mu power 1 by 2. Okay, done. Now let me rearrange this one. Okay, let me rearrange this one. So f by mu by f power 1 by 2 into L is the formula for the frequency. So KL power mu into mu into, so mu by f into 1 by 2. That's it. Okay. Right, no? So now we'll see the methods of dimension as the following limitations. So some limitations will be there, no, for this. So first one, cannot calculate constant values. Yes. So like 1 by 2 pi, those constant values we cannot calculate. So you cannot find the values of dimensionless constant. Second one is can't be used for complex equations. It doesn't work for the equations with trigonometries, exponentials or logarithmic functions. Then only work for multiplication and division. It works when quantities are multiplied or divided or raised to some powers, a or b or whatever it is. Okay. So these are the limitations is applicable for the problem which we have seen previously. Okay. Next is, we'll see some questions over here. Right, here is the question, is the homework question for you guys, okay? Is the homework question. So write the dimension of A and B in the relation P is equals to B minus x square by 80. Okay, this is the question. So there is a homework question, and one more homework question I am going to give. See, we have done the same method for V is equals to A plus U plus 80, B square minus U square equals to AS, and S is equals to UT plus half 80 square, right? So same method only we are going to use for this also. And one more thing, the last example we have seen, we have solved for the frequency, the similar kind of thing. Centripetal force F acting on a particle moving uniformly in a circle may depends upon, so F is directly depends upon mass, velocity, radius of the circle. Derive the formula for F using the method of dimension. So let us derive this one, okay? We will do this one, and the previous question will be homework for you guys, okay? So let me take F is directly proportional to mass A, velocity B, radius C, right? No? So what is dimensional formula for F now? So F has the dimensional formula m L T power minus 2 should be directly proportional to mass. So m power A, velocity L T power minus 1 power B, radius L power C. So let me take this m power A, L power B, T power minus B, L power C. So directly proportional, no, m L T power minus 2. So I can equate it now. A will be equals to 1, B will be equals to B, no, this is, wait a minute, let me take B plus C. B plus C will be equals to 1 again, okay, L, no, right. So T will, so minus B will be equals to minus 2. Minus B will be equals to minus 2. Minus minus cancel, so B will be equals to 2. So we got B and we got A. What about C now? So 2 plus C will be equals to 1. C will be equals to minus 1. So we got C. B is equals to, let me write properly here. So C will be equals to minus 1. B will be equals to 2. A will be equals to 1. That's it. So let me take here. F directly proportional to m power 1, V power 2 and R power minus 1. So mv square by R is the formula for centripetal force, right. So this is how we will do the problems when they are giving in this types, okay. I hope you got cleared about this right now. So you can take a note of this, yeah, this question you can take a note of this, and the previous question was a homework question, okay. So once before starting the next class, now we will do the homework question and we will start the class, okay. You can take a note of this, guys, first. Okay, so you want to take a question of, you want to take this question, na? Write the dimension of A and B. So if P is equals to B minus x square by 80. So where P is power, x is distance, t is time. So A and B are constants. Okay, now. So let's complete this session, okay? Okay guys, bye, we'll meet in the next class.